As important as changes in the nitrogen cycle are, the global phosphorus cycle is also important to understand for thinking about the metabolism of the Earth. Unlike carbon and nitrogen, phosphorus has only a tiny gaseous component and no biotic pathway that brings new phosphorus into ecosystems. So that phosphorus cycle in many respects is a lot simpler than the nitrogen cycle. And changes in the availability of phosphorus have a lot more limited effects than changes in nitrogen do. So of all the different cycles we've looked at, the global phosphorus cycle is relatively simple when you take a look at, especially at the fluxes going to and from the atmosphere. So there's a lot of phosphorus that's stored in sediments. The units here are in teragrams of nitrogen, just like we saw for nitrogen, deep water, surface water, and biota. And there's a lot of phosphorus that's stored in the deep water and surface waters. Soils, 150,000 teragrams. Vegetation, a relatively small fraction of that. And mineable P is about 10% of what we see in soils. So this is the amount of rock phosphorus that we can potentially use in terrestrial ecosystems. As far as the fluxes are concerned, in and out of ecosystems to the atmosphere, there's deposition, and that's mostly through dust. So we've got dust going up at 4 teragrams, deposition 3 onto land and 1 into the ocean. So most of the dust that's being produced, 75% of that goes back onto land, 25% of that goes into the oceans. More so than nitrogen is really the fluxes associated with erosion into streams and also out into the oceans through rivers. And so we've got mineable P that enters into agricultural ecosystems primarily as fertilizable P, and we're going to see erosion that's more than the amount of fertilizer that's added. So we've got net erosion from this system and 20 teragrams of P that goes into the ocean. So where's most of the phosphorus? It's going to be in the oceans and it's going to be in sediments. There's a lot that's in soils and there's a lot that's mineable and not very much that's in vegetation. If you take a look at the phosphorus cycle, we're at 13 teragrams of fertilizer P, and almost twice as much of that is eroded each year. So in this sense, the phosphorus cycle is a lot more important, is a lot simpler than the nitrogen cycle. And the important fluxes are really going to be all of this mineable P that adds phosphorus to agricultural systems. And then through a number of processes, we have erosion and the addition of P into these nearshore environments. Human activities have enhanced the mobility of phosphorus and altered its natural cycling by mining of phosphorus-rich deposits. So that mining is a really important source of phosphorus into ecosystems. And having this phosphorus accelerates the rate at which phosphorus weathers from rocks, and also by accelerating erosion in wind and waterborne transport. So when we think about really the anthropogenic changes to the phosphorus cycle, it's been mining and taking all of this rock phosphorus that really wasn't available to plants and distributing that onto ecosystems. That being said, in some ecosystems, dust is really important, and so the phosphorus demands are relatively low, and they can be met by the amount of phosphorus that's really deposited by dust. And we also have erosion, and a lot of the phosphorus that's being added to ecosystems is lost through waterways out of terrestrial ecosystems. This is figure 1411, and it shows the changes in global use of inorganic phosphorus fertilizers during the 20th century. And you can see it really wasn't until, again, 1950 that phosphorus fertilizer use was high. Here's teragrams of nitrogen, and I think we had something like 15 teragrams of phosphorus that were being applied as fertilizer. This number right here should be 10. So we got 0, 5, 10, 15, 20 phosphorus fertilizer used teragrams per year. And here's time. And this rate is relatively low. This is primarily guano and going to be animal manures. So we're somewhere on the order of 1 teragram. And since we figured out how to mine phosphorus out of rocks and apply it, there's been a steady increase in the amount of phosphorus that's being added to systems. And it's leveled off somewhere around 15 teragrams per year, right around 1980. It's important to note that there's a shorter legacy of phosphorus than nitrogen or CO2. that CO2, once it enters the atmosphere, there's going to be some residual effect for thousands of years. For nitrogen, because once it enters the atmosphere, it's going to be redeposited and it's cycled pretty tightly. Phosphorus, though, once it enters into aquatic systems, for example, or becomes immobilized in soils, really doesn't have much of a legacy. It's not going to get remineralized and made available to plants again. So we have to continue to add phosphorus, for example, and once we stop adding phosphorus, phosphorus availability is going to decline rapidly. So there's a shorter legacy of phosphorus compared to nitrogen or CO2.